China just pulled off something that Microsoft couldn't. They literally built a data center on the ocean floor. Not a concept, not a prototype. A real commercial facility. 2,000 servers, sitting 35 meters beneath the surface of the East China Sea, about 6 miles off the coast of Shanghai. And it went live just a few weeks ago. Now, before you write this off as some government PR stunt, hear me out. Because the engineering behind this is genuinely wild, and there's a plot twist involving Microsoft that most people don't know about. This video is going to break down how the whole thing actually works, why Microsoft tried it first, and then walked away, and what the real risks are, both to the business and to the ocean itself. Let's get into it. Before we talk about underwater data centers, we need to understand why the industry is desperate enough to even consider this. Every time you use ChatGPT, stream Netflix, or scroll through your feed, somewhere a data center is doing the work. And that data center is consuming a shocking amount of energy. Most of it just for cooling. Here's the thing about servers. They generate enormous amounts of heat. Dense GPU racks, the kind that run AI models, can consume hundreds of kilowatts, and nearly all of that energy turns into heat. So traditional data centers spend up to 40% of their total electricity budget just keeping the hardware cool. That's not running the servers, that's keeping them from melting. And then there's water. According to a report from the United Nations University, global data center water consumption could reach 9.3 trillion liters by 2030. That's equivalent to the entire water needs of sub-Saharan Africa. Data centers are massive. They need flat, stable land, access to power grids, and proximity to population centers to reduce latency. So you've got 3 problems: energy, water, and land. And they're all getting worse as AI demand keeps scaling. The industry needed a completely different approach, and someone looked at the ocean and thought, what if we just put it in there? China's facility is located in the Lingang Special Area, a designated high-tech zone near Shanghai. The data center is split into pressure-resistant subsea modules, deployed about 35 meters below the surface, positioned right between 2 phases of an offshore wind farm. The facility draws around 95% of its electricity directly from those offshore wind turbines right next to it. No long transmission lines, no grid dependency, clean power, generated basically next door, fed directly into the modules underwater. Now the cooling is where it gets interesting. Normal data centers use massive air conditioning systems or water cooling towers. This facility uses the ocean itself. The modules use a circulating copper pipe heat exchange system that transfers server heat directly to the surrounding seawater. The ocean absorbs it passively. No energy required for the cooling process. The result is a power usage effectiveness, PUE, reportedly below 1.15. Traditional enterprise data centers often operate closer to 1.5 or higher. The closer you are to 1.0, the more efficient you are. This facility is among the most energy-efficient, large-scale data centers anywhere in the world right now. It cuts land use by 90% and uses no fresh water at all. Right now, it's running at Phase 1 capacity, 24 megawatts, handling AI workloads, 5G infrastructure support, and big data processing. The long-term goal is 500 megawatts, about 20 times what's currently operational. The total cost was around $226 million to build. For comparison, a single large AI data center in the US right now can run into the billions. Here's the plot twist. This wasn't China's idea. It was Microsoft's. Back in 2013, Microsoft started exploring what they called Project Natick. In 2018, they submerged a container with 855 servers, 117 feet below the surface off the coast of Scotland, and left it completely unattended for over 2 years. When they pulled it back up, the results were genuinely shocking. Of those 855 servers, only 6 failed. Compare that to the 135 servers in a land-based data center over the same period, where 8 failed. In percentage terms, 0.7% failure rate underwater versus 5.9% on land. 8 times more reliable. Underwater. Microsoft's lead on the project believed the subsea success rate was down to 2 things. Filling the module with nitrogen instead of oxygen. Nitrogen is far less corrosive. And the complete absence of humans touching anything. On land, technicians are constantly walking around, replacing parts, umping hardware, introducing vibration and static electricity. Underwater, the environment was perfectly stable, so they proved the concept. The hardware worked better underwater, and then they shut the whole thing down in 2024. Why? Building and deploying underwater facilities required specialized marine engineering, offshore installation vessels, and complex grid connections, making costs far higher than conventional data centers. Maintenance also conflicted with the fast upgrade cycles used in cloud computing. Every 18 months or so, cloud companies need to swap out their hardware for something faster. On land, that's easy. Underwater, you have to lift entire modules out of the ocean, unseal them, swap hardware, reseal, and redeploy. Weeks per module, hundreds of thousands of dollars per operation. China's response to this problem? Don't repair individual servers. Replace entire modules. Smart in theory. But at 500 megawatts of planned capacity, even that approach has serious cost and complexity challenges. This facility has only been live for a few weeks. It's far too early to say they've solved what Microsoft couldn't. Let me actually walk you through what maintenance looks like, because this is where reality hits hard. A GPU fails inside one of those underwater modules. On land, technician walks over, swaps it out. Maybe 20 minutes. Underwater, you dispatch a marine vessel. Use robotics or specialized divers to detach and lift the module. Bring it to the surface. Transport it to a dry facility. Carefully break the seal. These are nitrogen pressurized modules, and a rushed opening can cascade damage across everything inside. Replace the component, reseal and repressurize the module. Verify it's airtight. Transport it back out to sea, and redeploy it. That's for a single component. And ocean water is one of the most corrosive environments on Earth. It constantly attacks steel. A microscopic crack in the seal is a disaster. A breach means water exposure and potentially every server inside is gone. This is the core tension. Underwater data centers can be incredibly efficient, but the moment something goes wrong, the cost and complexity spike dramatically. It's the exact reason Microsoft, despite proving the concept worked, decided to walk away. There's also a framing problem with underwater data centers. Since they use seawater instead of fresh water for cooling, they get marketed as environmentally friendly. And compared to traditional land data centers, the freshwater savings are real. But better than a land data center isn't the same as good for the ocean. Scientists have raised several concerns that aren't getting enough attention. First, thermal pollution. These modules are continuously dumping heat into surrounding water. At 24 megawatts, the local effect might be minimal. But scale this to 500 megawatts, or picture hundreds of these facilities deployed globally, and you're adding sustained, localized heat to the ocean. Warmer water holds less oxygen. Lower oxygen levels can suffocate marine life. A similar underwater data center, proposed off the coast of California, ran into environmental hurdles after scientists warned that the heat generated could trigger toxic algae blooms or create conditions harmful to local marine life. Second, chemistry. The modules are coated in anti-corrosion materials to survive the ocean environment. Over years of operation, could those coatings slowly leach chemicals into the water? We don't have an answer because nobody was seriously studying this until recently. Third, ocean heat waves. Studies have warned of the risk that unpredictable weather events like ocean heat waves could result in mass deaths of marine life, potentially suffocating animals in deoxygenated water. These facilities assume the ocean stays reliably cold. Climate change makes that assumption shakier every year. China's project reportedly went through stricter regulatory scrutiny than similar proposals in the United States. That's better than nothing. But the long-term studies simply haven't been done. This is genuinely new territory. And when something is new territory at this scale, The absence of evidence isn't the same as evidence of safety. So where does this leave us? China built something genuinely impressive. The engineering is real, the efficiency numbers are real, and the ambition is real. If they can solve the maintenance problem and operate at scale without significant environmental damage, this could become a real model for AI infrastructure worldwide. But they've also been running for a matter of weeks. Microsoft ran theirs for 2 years, proved the technology worked, and still concluded it wasn't commercially viable. China is betting they can do what Microsoft couldn't. With a first-of-its-kind facility in one of the world's busiest shipping lanes, the ocean covers 70% of the Earth's surface. As AI demand keeps growing, it was probably inevitable that someone was going to try building data centers down there. The real question is whether we figure out the environmental impact before this scales, or after. We make videos like this which help you in the chaos of tech and AI. If you found this interesting, subscribe so you don't miss our next videos.